I'm your friendly proctor today. You are in the Roman room for the 1145 talk of protocol level evasion of web application firewalls, a confession of a WAF developer. Your speaker is Ristic. And without further ado, here's your speaker.
Hello, and thank you for coming to listen to me today. I'm going to be talking about my favorite topic, which is web application firewalls. It's a sort of controversial topic because not many people like them, even those who deploy them. But the reality is that. So I can come closer, I can yell. So. As I said, web application firewalls are basically our reality today because in the last 10, 15 years, we've seen an explosion of popularity of web applications. And the reality is they're just not secure. And we need any help that we can get. And that's basically what web application firewalls do. The reason why I'm speaking about this topic today is that I care a great deal about web application firewalls. And I think they need to get better. And the only way they're going to get better is by talking about what they're bad at. So that's my talk about evasion. To kick off the talk.
Let's stop for a moment and put the wireless on.
I'm sorry.
I think it'll be better. That way you don't have to lean in like that. Let's just. Go ahead and go to check.
Check. Okay. Is this better? Yes. Okay, good. So now you've had more time to look at my question on the first slide. I wanted to start the talk with with an anecdote. A couple of years ago, I had an opportunity, a very brief opportunity, to test a web application firewall. It was one of those passive web application firewalls which were quite popular back in the day because if you have a passive device on your network, well, it's not going to break your applications. So people deployed them quite a lot. So I was trying to bypass this device because evasion was quite interesting to me even back then. And as it happened, I was able to bypass this particular product by adding on my first attempt, by adding a single character to an otherwise innocent request. And this single character was actually a dot that I added to the end of a host name. So, it happens, of course I was lucky, but it also helps that being a WAF developer, I knew a bit about how these things work. And if you're a passive device on the network, you know that performance is going to be your problem. So developers have to optimize in every step. And the way you optimize is you look at the host name of incoming transactions, and then you just discard the ones that do not match what you have in your configuration. So in this particular case, we had developers who didn't really anticipate the host name being slightly different. And that's why the evasion worked. And of course, after this, I was able to bypass, to send any attack to this particular web application firewall, and they all worked without being detected. I care about this topic a great deal because this is my 10th year working with web application firewalls. The first 7 I spent working on ModSecurity, which is a very popular open source web application firewall. And generally speaking, we need more transparency in the field. We need someone who's going to keep the vendors honest, because if we don't, we are actually allowing vendors to make decisions for us what's important and what's not important. So we have to put this thing into focus. So I'm going to talk about protocol level evasion, which is not your typical evasion topic. Most people, when they discuss evasion in web application firewalls, they usually talk about how to evade being detected when they're performing an SQL injection attack, so they obfuscate SQL. Or they may obfuscate JavaScript and HTML if they want to perform a cross-site scripting attack. So what I want to do is talk about impedance mismatch and actually focus on a very low level, a layer of web application firewalls where these products, security products, they have to interpret a stream of data. And impedance mismatch actually occurs where web application firewalls have a different interpretation of the same data stream as the backend web server or application they're being protected. If you think about it, what web application firewalls do, they make a lot of decisions, and every decision point is actually an opportunity for an evasion point. Here's a rough overview of the whole field of protocol level evasion. This is a representation of an HTTP transaction. As you can see, there's quite a number of fields there that you can use and you can try to play with. In my talk, although I've done research on most of these, in this talk, because we have a limited time, I'm focusing on the most interesting bits, which is the path, the query string, and the request body evasion. And all these other talks, all these other aspects of evasion will follow up later. To give some background for the discussion, I'm going to introduce virtual patching as probably the most popular use case of web application firewalls. Even today, organizations are really scared to deploy web application firewalls in blocking mode. But if you give them an opportunity and if they discover a known problem with their application, they will be happier to enable blocking just one area they know is vulnerable. But virtual patching, as exciting as it may be, because it helps you mitigate the problems and reduces the window of opportunity for the attacker, actually are quite demanding on web application firewalls because they require the WAFs to be very, very smart. And they have to parse and understand every single field. And of course, as I mentioned earlier, the more decisions that you have to make, the easier it is to evade them. However, the techniques that I'm going to be talking about are not just restricted to virtual patching. They apply to any sort of detection technique that has to deal, say, with paths and has to deal with, for example, learning. Many web application firewalls will have learning subcomponents where they actually build the model of the application they're protecting, and they look at identify individual scripts, individual parameters, and so on and so forth. So also as a background, I'm going to focus on Apache deployed with ModSecurity, simply because that's going to make the whole talk interesting. In the course of my research, I have located 2 previously unknown issues with ModSecurity and ModSecurity core rule set, which have been disclosed and fixed. But anecdotally speaking, all these issues are real, and you will find that commercial WAFs are also vulnerable to them. Now, I didn't test any of the commercial products myself, but what I'm going to be releasing together with this talk is a white paper which goes into more detail about all these techniques and a set of tests. And this is like a research toolkit that you can use in your environments to test what you have and to really find out how effective web application firewalls are. So without further introduction, I'm going to focus on path evasion, which is sort of the first aspect. What you're going to see in this talk is a bit of old and a bit of new. I think if there's one thing that I want this talk to do is to bring this topic into the focus and to open a conversation about this particular thing. Because I've spent years working on web application firewalls and had to deal with many of these issues, and I'm guessing that WAF vendors do too, but they're not talking about it. So that's why we have to do. So we have an imaginary application, and in that application there's a script called admin.php. Let's imagine it has a single parameter user ID, and this user ID is supposed to be a number, but it's vulnerable to SQL injection. So what you want to do, you want to deploy a virtual patch, and you want to make sure that if anything else comes in this parameter user ID, you can detect it so you can block the request and thus prevent the attack. So in the lower part of the screen, you can see how this is how you would do this with running Apache and ModSecurity. Conceptually, it's going to be the same with any web application firewall. What you do first, you have a patch activation first. Typically, this is done based on the path. And then you say, OK, this is where this patch needs to apply. In this case, it's myapp/admin.php. And then within the location block, you have a number of rules that actually check the content. In this case, we have just one rule, which basically alerts if the contents that we're seeing in the user ID field is not a number. So what we're doing is whitelisting. We don't care what attacks are possible. What we're doing, we're going to reject any request that doesn't conform to our requirements. So the first thing that you can try to evade, what we want to do is we want to evade patch activation. And probably the oldest trick in the book is to use a feature known as pathinfo, which is basically you just append the / and some random stuff afterwards. Web servers, which have access to the file system and can locate scripts on the file system, they know where the path ends. So that works for them. But web application firewalls they don't really know. To be honest, I thought this technique was so old that it was not going to work in real life. And I had been talking to some people about this, and they tried it actually on a commercial WAF, and this worked against a virtual patch. So even this one of the oldest technique. So the second technique is actually a very seldom used feature known as path parameters. To my knowledge, this is used only by the Java server specification to transport session IDs. And it has a similar, the approach is similar. You just append a semicolon, and then you put some random stuff there. You break the path, and then you prevent the WAF from detecting the path correctly, and you prevent the patch from running. So these two examples, they don't work in Apache because Apache's location tag will actually, it works like a prefix. That's all good. However, there's another way to write ModSecurity rules, and typically if you're distributing a virtual patch, you want to avoid messing with the Apache configuration, so you write a self-contained rule. Here you have an example. This is what we call a chain of rules. You have the first rule that will look at the path and decide if the patch wants to run, and then we have the second rule that actually enforces things. And all these examples that I'm giving you, actually these are examples of real-life virtual patches that I've collected on the internet. So all these are real problems. So there's a problem. There are a couple of problems with this patch. One problem is that the rule is using the string equality operator, which is very rigid, and it will only look for exact match. So both path info and path parameter attacks are going to work on this against this particular rule. The other problem is that there's a number of path obfuscation attacks that you can carry out, and these are known since forever. These are the multiple forward slashes, self-referencing directories, and back references. And as it turns out, using the rules as they are, they're quite easy to bypass. So there's a way, of course, to fix these issues, and one way to fix it is to use a better operator. Here, instead of the string equality operator, we use begin with. And then the other thing is we're using a feature of ModSecurity called transformation pipelines, where you basically provide instructions to ModSecurity how to transform input before it's used for comparison. And we have there's a ModSecurity, there's a transformation function called normalize path, which do exactly what as it says, does exactly as it says. We'll take a path, normalize it so it looks like a Unix path, and then we've addressed the problem. But every time we change our rules to fix a problem, we can just increase the complexity of the problem to see and to break it again. So imagine that we have Apache running as a reverse proxy deployed to protect an IIS web server. And this is actually quite a common deployment scenario. And once you deploy in a sort of diverse architecture, you have to start worrying about what the web server in the backend is going to do. And in the case of Windows, you actually have the situation that Windows will happily use the back reference / character as a path separator. And of course, the file system is not CAN sensitive. So how are you going to deal with this? Well, I gave it a shot. So Apache, using the stock location tag, is not going to deal with this, but it has sort of a fallback where you can resort to using a regular expression. So, so I tried. I gave it a shot, and I've arrived at a regular expression. It's pretty complex, but it seems to work. But, it's very difficult to use and very difficult to maintain. And to be honest, I've never seen anyone do this sort of thing. So, in every environment where you have ModSecurity deployed to protect a Windows installation, well, here's an easy way to evade. And of course, in ModSecurity, the solution is slightly different and slightly more elegant. We just use a different transformation function, and we apply the lowercase transformation function, and we apply the normalized path win, which is a special variant which will convert back references into forward references and do a few other things that a Windows installation would. But of course, we can complicate things further. If you recall path parameters, they're not actually path parameters, they're path segment parameters, and they can apply to any path segment. So we can put it right there in the middle of a path, and then we just put some random stuff, we break the path, and then we break the detection. So I went back to try to fix Apache, and I had to complicate the regular expression further And I think I've succeeded, but to be honest, it's not something I would be comfortable deploying in real life and committing to that works. And it's certainly not something that I think people can maintain. Would you try to explain this to your colleague? So in ModSecurity, there isn't actually an easy way. ModSecurity is lacking a transformation function to deal with this issue. So in ModSecurity, we have to resort to using the same complex regular expression. Of course, this is a usability problem. And the chances, as the complexity of these virtual patches increase, the chances of you doing it right, it becomes very, very slim. And we can go further, we can complicate the situation further. On Windows, of course, we have short file names, which are used for backwards compatibility. And it's very unfortunate if you have a script that has an extension of 4 characters, the short name will automatically be generated, and it's very easy to predict. So if you reference a file using the short file name, that goes straight through without the WAF, potentially without the WAF catching it. This particular technique does not work on the IIS, but it does on Apache running on Windows. If complicating things further, if you're in a particularly unfortunate situation that you have protect on a box running IIS 5.1, there's actually a number of different techniques which have generally been publicized in the past and which make it impossible very, very difficult to deploy a virtual patch or to deploy any sort of effective defense. Now, you could argue that IIS 5.1 is not something that you're going to find a lot in real life, but actually the truth is that WAFs are often deployed in order to protect very old legacy systems because no one wants to touch them, but they still they have to remain in use. So, by the way, in my white paper, I'm referencing all these, so I have a number of references. So as you're reading the white paper, you can actually go and refer and find these techniques and see why they work. So here's what I did. I think this is a major sort of deliverable of this research is that I've crafted 42 different tests that deal with path handling. These are 42 ways in which web servers are flexible and will take different things, and 42 different ways in which you can try to evade web application firewalls. I've tested several versions of the IIS web server, the Apache web server, and Tomcat. And if you look at this table, you see that there's a number of tests, and chances are in your particular environment, you will be able to find an evasion technique that's effective against that web server. And then the only question really is, well, is the web application firewall good enough to deal with the evasion issues? So that was the first out of 3 parts. I'm going to move to parameter evasion. This is the second step. So you have your virtual patch. Let's assume that patch activation worked. And now the second part of the patch has to be applied, which is basically you're taking parameter names and you have to verify what's in them. I think in this section is sort of a collection of a number of techniques. The first thing you could try is maybe you can just try supplying many parameter instances, or you can maybe use case variation. This is a very old technique. I don't think it will be useful in real life, except maybe against custom filtering techniques. But there are more interesting techniques. One of my favorites is actually the ability of PHP to take a cookie value and use it as a parameter, and it will appear in the request array. Although this is not supposed to be enabled by default anymore, it actually happens in real life, and I happen to have an installation of PHP on my laptop which missed PHP the configuration file, and as a result, I was able to inject any sort of attack payload by using cookies. And PHP is actually known for these things. The second thing that's quite useful is HTTP parameter pollution. This is where the backend modifies when you can supply maybe multiple occurrences of the same parameter, but then the backend will modify. So the WAF does not know what is the actual parameter value that's being used, and this is quite difficult to detect. So tricks with PHP parameter names. PHP has been known for a very long time to play with parameter names. So it's actually very simple. It's as simple as providing a single white space at the beginning of a parameter name. And if you put a little plus there, PHP will do you a favor and it will remove all the white space at the beginning. If it finds a couple of interesting characters inside the parameter name, it will replace them with an underscore, which is very convenient because often parameters will have underscores. So this is yet another way to perform evasion. Then you can use invalid URL encoding, and this is one area where WAFs have it particularly tough. So if you look at ASP, if ASP encounters an invalid URL encoding, well, it will remove the percentage sign. So this is quite useful for parameter name evasion, but it's actually more useful for content evasion. You can submit any payload to it, and you can place a number of percentage sign within your attack payload, and ISP will be very helpful in remove those for you. On the other hand, PHP will leave the percentage sign. And then also in the third case, we have some applications that convert invalid URL encodings, no matter, because they rotate and they just rewind. You can find unusual combination of URL encodings that will resolve to correct character, and actually that you can use that to craft a payload that actually works. So this is something that WAFs cannot really easily deal with, because the number of false positives they would create are really, really big. But I think the biggest problem with parameter name evasion is in the case where you submit parameters in the request body. If your parameters in the query string, that's sort of easy. WAFs know where the query string is, and the only thing they have to deal with is the URL encoding. If you have parameters in the request body, they first have to detect the encoding, and they have to apply the same parsing to the request payload as the backend application would. So what happens in the case where you have a backend application that has a hard-coded processing? Usually it would be URL encoding format. First, you can omit the content type header altogether, and then you can place an arbitrary value in it, and many of these products will just ignore. For example, ModSecurity is known to just ignore any request bodies whose MIME types it cannot recognize. Even if you enforce, and if you require content type to be present, well, and yet if you have an application that uses the hard codes URL encoded parsing, you can just send multipart form data. This is something WAFs will understand, but they will not know that what you're actually supplying is a URL encoded format, which will be recognized by the backend application. And then also you have many other issues with libraries that are very lax in how they detect MIME types. And this is another problem I discovered. I was researching Apache Commons File Upload, which is a very popular library for parsing uploads. And you could say it's the de facto standard in the Java space. And with servlet specification 3, because file parsing is file uploads are included in the specification, Tomcat now actually includes this library and uses it for parsing. Well, I've discovered that the file upload library will actually accept as multipart form data anything that begins with multipart and then a /. So what this means that, say, you can perform a ModSecurity bypass simply by sending a multipart / whatever is the MIME type. So what will happen is that the library will recognize this is multipart form data and parse it, and then ModSecurity will see a MIME type it doesn't understand, and then it will ignore it. So this is again a difficult area, because if ModSecurity, for example, shipped with restrictions on MIME types, that would create all sorts of false positives and create usability issues for people deploying it, and then would create a bad vibe for the user. So I think ModSecurity, what we have here, is sort of errors on the usability side. Of course, there are other approaches here, and the approaches commonly used is that you can use JSON file formats, which not many web application firewalls know. And then my colleagues have a talk tomorrow about WebSockets, and you can use WebSockets, which even fewer WAFs understand, in order to submit these payloads and make them work without the web application firewalls detecting them. So this is my second part. I want to move to the third part, which is sort of the part that I'm finding most interesting and very challenging. It's the part that I've spent a long time working on while I was developing ModSecurity. And back at the day, I didn't have enough time to publicize these things. And the reason why we came back to actually research evasion issues is that at Qualys I'm working on a new open source web application firewall. It's called IronB. So normally we started to develop it and we want to make it very good. And we've realized that no one has actually covered these issues and there isn't a comprehensive coverage. So we are doing it because we need it. And we're also sharing our research with everyone else so that other WAFs can be improved. So here's what a multipart form data encoding looks like. So unlike the URL encoded format, we have a really complex format, and also the additional problem is not very well documented. Actually, if you look at the spec for this for multipart form data, it refers to a couple of other RFCs, and which are a mess. The format is modeled on the MIME specification. So in reality, what we have, the standard is whatever works in real life. In order to successfully process a multipart form data payload, a web application firewall has to do at least 5 things, and there's more. It has to first correctly identify the MIME type, multipart form data, and as we've seen, that doesn't always work out. Then they have to extract the boundary, and then they can use the boundary to process the request body. And by using the boundary, they will extract individual parts. Each individual part corresponds to a parameter or a file that's being uploaded. And then a part consists of the headers, which can actually quite complex. They model HTTP headers. You can have anything there. You can even have header folding. And then after the headers, there's actually a part value. You can see the only difference between a parameter, in my example, there's a parameter called name, and a file is the file will have additional parameter on the content disposition header, which is file name. So it's actually a problem that, so if we look back at Apache Commons file upload, let's see how they're detecting multipart form data. As discussed earlier, they just look for anything that begins with multipart slash. So this makes it very easy to evade. And the thing is, ModSecurity, even though ModSecurity itself doesn't enforce and doesn't have any restrictions on MIME types, ModSecurity core rule set, which is a sort of official distribution of rules for ModSecurity, ModSecurity core rule set does. However, in researching the implementation of the restriction, I found it, ironically, the restrictions themselves are lax. And that if you supply a multipart forward slash MIME type, that will satisfy the core rule set, that will satisfy the Commons file upload library, and they will parse it. Unfortunately, ModSecurity itself will not see this as a valid multiple from data, and again, evasion will work. So of course, we have a number of these issues. Multipart evasion is quite complex, and there isn't enough time in this talk to cover all individual cases. I have about 37 cases that I'm releasing on GitHub. So what I'm going to do instead, I'm going to cover types and blocks of evasion cases. And this first example is when you're trying to fold the web application firewall into not seeing the MIME type. And you can see these variations. You can use all the usual tricks. You can use case variation. You can try to break the content type request header in various ways so that it breaks when a WAF attempts to parse it, but it works when the backend tries to parse it. So here, the last 2 examples here are what worked with the ModSecurity core rule set and what worked with the Apache, with ModSecurity and Commons file upload. Very enlightening is that we can look at the PHP source code, and this is very representative of how libraries handle multipart form data. And this is an abbreviated piece of code that shows how PHP looks for a boundary. Knowing the correct boundary is very important. If you have the web application firewall see one boundary and PHP see another, what you're going to get is that the WAF is going to see one set of parameters and the PHP is going to see another set of parameters, and of course evasion works. And the first thing that becomes apparent when you read the source code, actually PHP will not attempt to parse the content type header properly. It will just use crude string matching, and it will look for the word boundary anywhere in the content type header. And by itself, this is very prone to evasion, because you can have a couple of these, and then then you don't know exactly what's going to happen. Of course, PHP will try with the lowercase variant as well, if you cannot find it on the first try. And then something else interesting happens. After it finds the word boundary, it's going to look for the equal sign, but not immediately following the word, but anywhere in the string after the word. So actually, PHP will match on boundary equals, but it will match on boundary 2, boundary 3 equals, and you can put any sort of other stuff there, and you can use all this stuff to confuse the web application firewall. And again, here we have examples of various things that generally speaking work, or can work depending on the product that you're testing. And all these tricks, they sort of, the basic principle is the same here. You supply 2 boundary values, and you have one boundary value for PHP, and then you have the other boundary value for the WAF. And depending on exactly how WAF will handle. So if you encounter a WAF that is not plainly rejecting any content type string that contains more than one boundary, chances are it will be vulnerable. Because then you only have to find if it will recognize the first or the second boundary that you plant, and then you just have to work out how to make PHP happy, and then you're done with your evasion. So multipart evasion is not something that's been discussed, as I mentioned earlier. I think the only instances that we have of someone looking at multipart evasion is Stefan Esser in his 2009 talk, and I think he highlighted 3 issues. So the last issue, this is something that was published in 2009, and this exploits the fact that web application firewalls try to do things properly, and that's a big pitfall. That's what I tried with ModSecurity. That was my first attempt. I was really, for example, really proud when I implemented my first cookie parser, and because it was just following the specification. And then as it turned out, if you follow the specification by the word, it's actually quite easy to evade you, because in real life, no one really does that. So here we have this. The reason the last example worked is because that particular F5's web application firewall would stop recognize the single quote as a boundary termination character, and it would see just 4 zeros as the boundary, and PHP would see the whole thing. The second thing, and now we're progressing down the list, is part evasion. This is something PHP used to do. In the multipart form data, you're supposed to indicate your last part, and then processing should stop after the last part. Well, as it turned out, PHP would continue to process them. So if you implement a web application firewall that does things properly, then you have yourself an evasion. Parameter name evasion is also very interesting, and this is sort of the same trick. You have in the content disposition header, you can supply multiple name parameters. And most parsing implementations will actually happily process them, and sometimes these implementations will take the first one that you plant, and sometimes they will take the second. I have 2 examples here. So in order to bypass a web application firewall, what you do, you first send a content disposition header with 2 names, and then you look to see which of these 2 names the WAF will use. And then once you find out if it's using the first or the second variant, of course, you can find it is blocking, which is the ideal situation. Then you just craft your payload to avoid detection, as to again use a second value for PHP to consume. So using the 2 examples that I have on the top there, this is how PHP would see it. In the first case, it would see the second name, and in the second case, it would see the first name. So again, this is something that's very easy. Most of these attacks are actually trivial to perform. Finding exactly which payload works can be mind-numbing, because you're dealing with just character variations, and there's a ton of them. But generally speaking, if you have the patience to sit out and go to the whole list, in many cases the evasion works. And the final parameter type evasion that I have is multipart evasion that I have is parameter type evasion. This exploits the fact that many web application firewalls actually treat files differently. In ModSecurity in particular, if you're uploading a file, there's no inspection done on the contents of the file, which is sort of tricky. I think if there's one thing that ModSecurity needs to do, it needs to start inspecting file contents, and it also needs to start inspecting the contents of request bodies that it doesn't recognize. Well, so this would sort of improve its chances of finding attack payloads. So Stefan Esser actually reported a problem in this area back in 2009. This is after I left the ModSecurity project, so I wasn't actually involved in this area and didn't pay much attention at the time. And I rediscovered this problem in my own research and through reading of the source code. And what I actually discovered is that, so here's the original problem. What was thought at the time is that PHP actually does something very unusual in the way that it parses multipart form data. It will allow single quotes for quoting. And because PHP knows this, and WAFs typically will not, you can craft a single string of data to mean one thing for the WAF and of course the other thing for PHP. And this is why the payload works. If you look at it, in the first case you can see what ModSecurity sees, and ModSecurity will see one name parameter which the contents will be just a single quote, and then the file name parameter, which has some rubbish in the payload. And then PHP, because it uses single quotes for quoting, it will see two name parameters. And because PHP uses always the last parameter that you supply on the content disposition line, then it will use the second one, and PHP just treats this particular parameter as a parameter and not as a file, and then the evasion works. So as I was reading the source code of PHP, I realized that the flaw had been misunderstood. The problem is not actually that PHP used allowed single quotes for quoting. It's actually it also decoupled the parsing of key value pairs from the actual quoting mechanism, so the quote can appear anywhere, not just as the first character in a key value in a key value pair. So I was actually able to add a single character to the original payload. And again, this would completely bypass ModSecurity, because ModSecurity would treat the file, this particular part as a file and not inspect it. And I can tell you that I've had someone test at least another commercial web application file was vulnerable to the same problem. So in reality, I rediscovered this problem, and then only following up with the research, I realized that this is exactly the same, almost exactly the same payload as Stefan Esser originally discovered. And this has been reported to ModSecurity about a month ago, and it's been reported to have been fixed in 2.6.6. But generally speaking, it's a very rough area. Multipart form data is a very rough area for web application files. It's simply not possible to anticipate every possible flaw in the backend implementation. So the only solution, what you have to do in the WAF is you have to double check, triple check, and you have all these weird and paranoid things that you do in your check in order to ensure that you're not being bypassed. So this is the summary of the multipart evasion. As I said previously, it's a very vague area. It's very prone to evasion. I wouldn't be surprised if there are more issues here. And I think certainly that in my 37 cases, I'm sure that they could be improved. And I actually have a number of other items on my to-do list where I want to revisit this particular area. You can download this test from the repository. I've only tested ModSecurity in Apache because this is what I had access to. I'd be really interested to see how other web application firewalls do. Anyhow, talking about the evasion techniques, the thing is that if you look back at the history of evasion, the history of security problems, you realize that we haven't done a very good job at documenting previous problems. So what you're seeing is that every new software that is being developed, let's say someone decides to write a web server tomorrow, well, that person, because we're not documenting our history very well, that person is going to make all the same mistakes all over again. So I think this is why I think it's very important, so that we bring this, and this becomes enters the public body of knowledge, so that we can bring the bottom up. This is all for my talk. This talk presents just a part of my work, everything that I could fit within the hour. I should have probably presented less stuff and go into more detail. And I have a bunch of other notes. So what we will do, we will continue to research this topic, and we will continue to release new information as it comes. We have all this stuff in a GitHub repository. We have a wiki. Our intention is not only to focus on the missing bits. In particular, I find HTTP parsing very promising. Character set issues, we found some character set issues that make evasion possible. And of course, hostname evasion, which is my favorite, which I want to revisit. Going long term, we want to build an evasion catalog, basically, and expand focus not only protocol level evasion, but all evasion techniques. We're making this wiki open, and we're hoping that others will join. You can find the wiki on GitHub and all the material here if you go to github.com/rb/WAF research. And if you're interested, this is something that you can play with. And hopefully, if you find some interesting stuff, report back to the project. Personally, I don't care about which web application firewall is vulnerable to which evasion, but I think it's important that we do know where these problems are. So what I can do, because there's still some time left, I'd like to share something with you that I found particularly insightful, and something very powerful that resonated with me is when I was going to the Donald Kennett's web page. He doesn't have an email. Well, he does have an email address, but he is not using it. And he's finding email too disruptive. And he has this quote which basically says that being on top of things is not what he's interested in. I think that his role is to be on the bottom of things. And I think in this industry we need to do more. We need to be on the bottom of things rather than to try to be on the top of the things. Because if we don't bring the bottom up, we're never going to learn, and whoever follows is not going to be learning anything. So I have some more time left to give you a quick demo. Now I promised a demo. I don't find it particularly interesting. So what I have here is I have a web server. And I'm going to demo the ModSecurity Bypass. If you have ModSecurity 2.5.5 running. And I have a very simple script, that PHP script, that will simply bounce back whatever parameter is sent to it. So you see in this case I've sent the parameter user ID and its value from digits from 1 to 8. And what I have is I've configured ModSecurity to block any transaction that has the word John in it, case sensitive. And what I'm going to do is I have two screens here. Let me move this. So I'm going to look at the error log. Let's scroll this. And here's I have a normal test. So this is an example of multipart form data. And you can see here, no you can't, but you will see now, we have the name parameter, and the name parameter contains John Smith. So what I'm going to do, I have a very simple utility, and this is what we're releasing, that I can use to play this payload against. Now I need to resize my window. Okay. So if I send this particular request to the web application file, you see that it responds with a 500 internal server error, which is good because that means that I role matched. And you can say that the script itself detected this transaction is blocked. And then if you look at the result, you see that access has been denied because we found the word John in the payload. So okay, so we know that works. So let's look at the alternative. Let's look at the actual test from the payload. And this test uses the trick, which I showed to you earlier, supplies all of this as the name field. And what I'm going to do, I'm going to play it to the web application firewall. And what you see there that nothing happened. Basically, the application responded with a 200 response, and you can see the PHP bouncing back the payload. You can see that PHP here sees the name John Smith, but obviously, if you look at the error log, there's nothing in the ModSecurity error log. What we can do is we can look at the debug log, because I've enabled the debug log, which is very verbose. This is not something that you would do in production. And here's ModSecurity trying to parse the payload. It sees the entire payload, but it extracts the name as X, single quote, and then extracts the file name as something it doesn't look right. I should mention that the ModSecurity core rule set actually had a rule as a good example of defense in that ModSecurity core rule set had a rule to catch this particular thing, and it did. The only problem is it would catch it if you had the core rule set deployed in blocking mode, but if you had it deployed in anomaly mode, the anomaly value assigned to this particular discovery was too low, and it was still possible to bypass both ModSecurity and the ModSecurity core rule set. So this is it, I think. I think I'm done with my talk. Thank you very much. If you have any questions, we have a mic over there just behind the camera. If you could please just ask your questions from there. Thank you very much.